I will introduce our next speaker. So we actually have two from the Air Force Research Laboratory's Materials and Manufacturing Directorate. So Mr. Darrell Phillipson is a member of the Senior Executive Service. He's the Director of the Materials and Manufacturing Directorate, Air Force Research Laboratory at Wright-Patterson Air Force Base. In this capacity, he leads the Department of the Air Force's Science and Technology programs in functional materials, structural materials, manufacturing technology, and system support for advanced next-generation space missile and aircraft applications. He has held numerous Air Force roles, including serving as the Air Force Science and Technology Authorizing Official, the Air Force S&T Principal to the Department of Defense High Performance Computing Modernization Program, and the Air Force Research Lab's Chief Information Officer. And with him is Dr. Bill Bernstein. Dr. Bernstein is the branch technical advisor of the Digital Manufacturing and Supply Chain branch in the Manufacturing and Industrial Technologies Division of the Materials and Manufacturing Directorate at the Air Force Research Lab. He leads the Advanced Manufacturing Technologies ManTech product portfolio, which comprises of the Additive Manufacturing Digital Enterprise and Future Factory programs. He is also part of the RX Digital Manufacturing Research Team, which internally addresses challenges faced by the Air Force and Space Force services. He has received multiple honors and awards. Examples include the 2019 ASME Computers and Engineering Young Engineering Award, and in 2020, the Department of Commerce Bronze Medal Award for his contributions to the ASTM Sustainable Manufacturing Standards. So with that, I will turn it over to Darrell and Bill.
All right, we got me 5x5 on video and audio.
You're good to go, loud and clear.
All right, hey, thanks, Mark, and also thanks, Karen, Emma, everybody else to help put this on. First of all, I want to thank the Ohio Federal Research Network for putting these on. I'm not the first director who's had an opportunity to use this as a platform just to kind of share perspectives and help us work together and collaborate together. So I love it, and I'm honored to be a member on today's panel. I will say, Mark, I listened to your kickoff when we started, and you said you're sure that each of us could speak for hours so on this topic. So it's either through sheer level and amount of knowledge, or you just kind of thought we were long-winded. So either way, we can talk for hours. Let everybody be the judge.
I did spend 37 years in the Air Force, and so I understand how that goes.
So Dr. Bernstein and I have really a tag team presentation here, so thanks for introducing both of us. Quite honestly, I only have a few charts up front. I've been in the role for 6 months now, and boy, there's a lot going on here in the Materials and Manufacturing Directorate, but I've been involved with the Air Force Research Lab since before we became the Air Force Research Lab in 1996 as a lieutenant. And I've been kind of involved from perspectives of, well, as an officer, enlisted before officer, but officer, contractor as with a small business, worked for Lockheed Martin for a while, did financial stuff for a while, and then as a civil servant since 2007. So what I want to kind of do with a few charts is just go big to small, right? Just give you a sense of, like any company, you start out and you kind of need to understand where do they get their needs, where do they get their demand signals, what's the breadth of the type of work that we're doing, and then specifically what's our vision, mission within the Materials and Manufacturing Directorate, and give a sense of how big are we, big business, small business, where do we fit in this picture. And then for the technical talk, Dr. Bill Bernstein, as you mentioned, he's our technical leader in digital manufacturing and supply chain, so he'll kind of take over and walk through giving you insights for our portfolio. So if you go to the next chart. This is a chart that our commander will present sometimes, General Heather Pringle, and you might have heard over the last several years that the Space Force stood up, and I'm not sure the level of interface that all the members have with the Air Force or with the Air Force Research Lab, so bear with me. It's only a few charts, but over the last several years, they stood up the Space Force, and the Air Force Research Lab is really what I would call the department of the Air Force Research Lab, which serves both air, Force and Space Force. So there's not a separate Space Force lab. So it's one lab supporting two services. And you see there at the top of the charts, Air Force and Space Force Science Technology. And this is kind of just a big kind of a site picture. Lower right-hand corner is taking in those environmental factors of what's going on in the world that impacts the DoD and specifically and uniquely the Air Force, so the Department of the Air Force, of course, working with our other service partners. Those environmental factors are things that you all might see, but it also might be threat-informed briefings that we have the benefit of being able to bring together. We take that and then then we look at, you see that block that says mission and core functions is looking at, okay, within the scope of what's happening in the environment, what are the things that we need to achieve as an Air Force? What are those capabilities that need to be delivered? And what are the technology gaps? So it's very fed, very rigorously vetted and fed by that kind of chain. You look at the very center there, National Defense Strategy. That's a core document for us, but we get other guidance. If you've heard of the Secretary of the Air Force setting out the operational imperatives, or if you have not heard of them, go find them. They've been publicly released. Those operational imperatives help you understand where the writ large, the Air Force is trying to focus in creating capability for the future. So very insightful. We decompose that and look for what are potentially, you might say, the technology imperatives that are necessary to create that capability. And always within our mission, we're looking at, how do we balance that demand signal, which tends to be nearer term, with our needs, which extend not only near, mid, but also into the far. A unique mission for the Air Force Research Lab is to ensure the Department of the Air Force avoids technical surprise, technology surprise, which isn't necessarily a known need or demand signal, but it's us getting out there. So with us doing that, then we look at how do we partner, because our lifeblood is partnering, not only with industry, academia, internationally. That's how we leverage, and that's how we all work together. If I go to the next chart, this is something that I actually pulled this together because I think it's important that when you're working with an organization, whether it be commercial or with us, it's nice to not only understand where they see their environment, but where do they work along the spectrum. From, if you look at that funnel, are you working basic science? Are you working that applied technology? Are you more in the sweet spot of prototyping and experimentation? Or are you on that far right where we're really working implementation of existing technologies and engineering kind of solutions to develop, to create and produce and deliver, products at the end? So where does AFRL work along the whole spectrum, right? So I kind of organized our sub organizations, the units that are part of the greater Air Force Research Lab, a little bit left to right, but please don't take it too literal. We have the Office of Scientific Research, which really does do all the 6-1 basic research and really funds that work throughout AFRL, but throughout industry, throughout academia. 711th Human Performance Ring really works along the whole spectrum with on the medical and human performance lines, and I think you might have had them present before. Materials and Manufacturing, I'll get to our mission, but we are one of the unique ones that has a very heavy weight towards the foundational science. But if we create materials that can't be produced and manufactured and made at scale, then that's not very useful. We also have the Information Directorate. Our Sensors Directorate is pulling multiple technologies together to create systems, sensor systems. Directed Energy Directorate, space vehicles. Now you're working generally from systems to system of systems. Same with munitions. You're looking at the whole munition. Aerospace systems works on the engine and the platform. And again, all of these have some work in the 6-1 early research, some of the 6-2, the 6-3, and try to make sure that we are transitioning to the warfighter. But I just thought I'd kind of go through all of these so you got the scope of what I'm talking to today is really the materials and manufacturing. It's one of those groups. You also see on the right, we have a couple of new constructs. AFWorks, who is out there trying to get creative, new ideas, different funding sources, bring in leverage industry as well. And then our latest one is the Integrated Capabilities Directorate. And that's a unique function that we stood up over the last few years, a director, Mr. Chris Ristich, that very much is focused on that far right of pulling teams together from across AFRL to stitch together and deliver and to demonstrate and deliver capability, not in the near, well, some in the very near term, but also in that midterm is pulling all that together and delivering those capabilities. So sorry I spent a little bit of time on that, but hopefully it's a little bit of perspective that you don't always get. If you go to the next chart, I'll just cover. So my role, I'm the director for the Materials and Manufacturing Directorate. Vision is pretty simple. We invent the stuff that makes the future. There's 4 main words there: invent, stuff, makes future. So invent is really hearkening to that point that I made earlier, that the Materials and Manufacturing is very, very weighted as a foundational technology directorate. So a lot of 6.1, 6.2, not that we don't get into the 6.3 and work on many other projects where we supply that support to make the materials affordable, to bring forth exquisite new materials. But we really have a strong weighting on that invent. And when you look at our workforce, we have a very high level of PhDs, and that's because we have that credibility on that invent side. The stuff that could be new materials, that could be more affordable materials, that could also be processes and processing technologies. Makes, if we can't make it at scale, it's not any good. And of course, our focus is not as strong in the rearview mirror. It's more strong on that future capability that we need, and that's that emphasis. So if you look at the circle there, starting at the very top, we do everything from discover, that's 6.1, 6.2, to develop, getting it ready to actually integrate into capabilities. And then we look beyond, working with industry on how do you scale up. If you got a coupon of material and it has great promise, if you can't scale that up, if you can't manufacture it, which is the next block with and is supported by our role in executing the Air Force's manufacturing technology ManTech program, then it's really not something you can apply and help the warfighter. And then if you go beyond the manufacturing, we execute the Air Force. Actually, we execute. Do we execute the whole DoD? I'll say we execute the Air Force portion of the Defense Industrial Base Title III program. Bill, you can correct me if you want to. I just had a glitch there. And then, of course, all the way up through deployment. And deployment, we're not the deployers of technology, but we have a lab that supports those deployed systems, like a field laboratory, really, where we learn and then are able to close that loop. So you're going to go to the next chart. Just a few top-level facts about the Materials and Manufacturing Directorate. I like when I'm talking to a group to understand, are they a Lockheed Martin? Are they a Boeing or something? Are they, how big are they as a small business? So within the research lab that does have about 10,000 people, we're about 1,200 folks strong as total force. That's our contract support as well. We have 400,000 square feet of facilities here at Wright-Patterson Air Force Base in Ohio. About half of that is lab space. To be honest, we have 300 lab modules. Like I said, we're not a building of program managers. We're a building of scientists and engineers rooted in that foundational technology. We're here at Wright-Patterson Air Force Base. I think there is a I got an old version of the charts here too. The core S&T there, the reason I state core is that we also execute another over 1.5 billion in Title III and other people's money. Title III is a really big program that we execute on behalf of the DoD. So on the right there, I won't walk through those. That's kind of a laundry list of the types of things we focus on. We're not talking about all of those today. In Dr. Bernstein's talk, he'll touch upon kind of those things that are highlighted in right on the right or in yellow. He's not going to list and name all of those and make some alignment, but that's kind of the types of things that are impacted by the technology and the interest that Dr. Bernstein's going to cover. So with that, I think it's time for me to hand off to Dr. Bernstein.
Thank you, Mr. Phillipson. To be clear for everybody, can you please go to the next slide? Just to be clear, these are a bit old, outdated slides. We have a public releasable version of these slides without the markings that you see on the screen here. So we'll be happy to share that, and you can distribute it across the rest of the folks that participate. Today I'll really focus on our ManTech portfolio. And for those that speak technology readiness levels, I think that's the easiest way to explain what the wheelhouse of ManTech core funding is. So those projects that are met with basic research or 6-1 dollars need to be scaled up and make sure that those technologies are manufactured at a reasonable level. I'm sorry, Mr. Phillipson, do you have your hand up? I see a hand raised.
Oh, sorry, Bill. I thought the precedent was to raise your hand if you wanted to go offline. I was going to ask the moderators if they could switch to the public release version. There's nothing in here that's not public release, but if they can switch to the public release, that'd be great.
Okay, no problem. So for those technologies that meet the need of, let's say, lab demonstration, ManTech core funding is really meant to scale those up and show and represent them in representative environments, for instance, like our sustainment depots. A quick note that the Air Force is actually the only service across the rest of the ManTech receiving organizations, for instance, like Navy and Army. Air Force is the only one that houses its ManTech program within the research lab itself. So I would argue that we really have a great opportunity to quickly scale up great things coming out of AFRL as a whole, and particularly RX. So I hope that we touch on some of these key areas related to smart manufacturing and IoT, which Professor Hill really touched on nicely before this presentation. Please, next slide. So for context here, before I came over to AFRL about a year ago, I spent 6 years at the National Institute of Standards and Technology. And certainly vocabulary, taxonomies are critically important to NIST folks and NIST adjacent people. And there are many different definitions, as Professor Hill alluded to, on smart manufacturing, or commonly known as Industry 4.0. But the one that I like the best is the combination of advanced manufacturing services and state-of-the-art IT infrastructure. Often people use this term of combination between operational technology and information technology. I would just argue that the lines between OT and IT are already quite blurred in terms of what you can purchase straight off of a market vendor. So I think it's a little bit more nuanced than that. I've provided some examples of what would constitute a smart manufacturing project. For instance, if you were to institute some advanced machine vision algorithms together with heavily automated process, surely you would fall within that space. Our portfolio ranges across many different manufacturing services. Primarily, we are really focused on additive manufacturing. We have an entire ManTech program around that. Our partners across RX are focused on flexible or hybrid electronics or functional materials. And I would say that across RX, we're trying to find these interesting combinations between what's the latest and greatest from the digital infrastructure world, for instance, using extended reality or advanced visualization modalities, along with different ways of interacting with data, whether it be through visual analytics, ontology, or other kinds of knowledge representation techniques. To me, the Internet of Things plays here, specifically on the scalability of these smart manufacturing technologies. The more connected devices we have, the more we learn from different installations And it's easier for us to gain trust in pushing those ideas across processes and across platforms. Please, next slide. So there's a lot of information on this slide, really here for your intake maybe later. The key point that I wanted to make here is that we really can no longer talk about industrial Internet of Things without security. And I think Professor Hill also made the same exact statement or similar. And this notion of DevOps, which is kind of the foundational approach to modern software development, where the development along with constant testing and operational control of that software has now been essentially expanded into the security space. We can no longer take for granted prototype software, place them on our OT systems without engaging directly with security constraints and requirements. And one key note that I wanted to make here is that all of the different IT providers, and I didn't mean to leave anybody out on the slide, just a couple examples, that they themselves, for instance, Amazon Web Services, are enhancing the security of each one of their microsystems pretty much nearly every week. I put every month just to be safe there, but if you take a gander at that that link that's on the slide here, you'll see that a lot of the traditional and basic or foundational microservices already have reached an IL4 and above requirement, which is fantastic for DoD services. We cannot deploy cloud services that do not meet these security requirements, and having more prototypical software elements that are able to operate on the cloud allows us to really push the bounds of our research. Next slide, please. So I don't think it's any new news to anybody that across the kind of our communication channels and public affairs channels, that smart manufacturing, industrial Internet of Things is certainly surging. And we agree that the future still remains in the digital space, meaning that additional science and technology development is required to bring these up at scale. We already see our aerospace primes, many of which I actually met with the last 2 days over a technical data package monetization workshop. Many of them have already installed cells and sometimes lines that are able to deal with high mix, low volume scenarios, instituting automation and robotics with very fine precision, yet scaling them across the industrial supply chain still remains a critically important and difficult thing to do. You need considerable capital up front to produce these tools. And of course, what kind of underlines a lot of these issues in terms of data portability and interoperability is, I wouldn't say the lack of available standards, but rather the lack of adoption across some of the large providers. Next slide, please. Okay, so we have some very exciting work already going on within the AFRL walls, but then also with partners that really make use of the smart manufacturing and industrial Internet of Things combinatorial effect. And I will touch on some of these topics later and how we have framed our current advanced manufacturing technology ManTech portfolio. But these just give a snapshot of some of the benefits that we've already seen directly and have already returned very nicely for DoD dollar. In the top left, you see the idea of backstreaming downstream data, for instance, in-flight operational simulation back to design, putting it in the hands of those that are actually going to fly those systems so that we can have better design requirements to meet the needs of our warfighter. On the top right, I have a snapshot of a really fascinating laboratory already deployed within AFRL RX, which is termed Leroy. It is essentially a robotic cell, multiple robotics moving coupons around for material characterization inspection using some of the latest digital transformations. I'll be happy to discuss that more for those that are interested. On the bottom left, we see an example of what we call bringing the process to the part rather than the part to the process. So this departure from monumental robotic systems and being able to build agility within our sustainment procedure. So in this case, you see a fully autonomous robotic arm deriveting off of an aircraft wing. And on the bottom right, something that we're just now getting into, which I think is of critical importance, is how do we build software ecosystems in a more accessible way? And I'm trying to highlight, we have a network of internal software factories that look at low TRL aspects of schema development and software deployment and prototyping. Be happy to discuss that more if interest is there. Please, next slide. So I won't get too much into what I consider to be Industry 4.0, but I will say that this fourth industrial revolution aligns very well with our existing AMT ManTech programs. And those three were already listed by the kind introduction before we took the stage. So we have a program called Digital Enterprise, which aligns very, very well with MXD Manufacturing Institute in Chicago, with the idea being that we're focusing on how we can improve model-based everything to enhance manufacturing and design procedures. Secondly, we have a fairly large additive manufacturing program, which again focuses on high mix, low volume scenarios. Right now, we're taking a turn to focus on expediting qualification schemes. So for instance, if I lose a powder supplier for whatever reason, how am I able to quickly qualify the next part coming off the line with the new powder that is to be fed into my machine? We are strongly tied with America Makes, so lots of our efforts run through that manufacturing institute. And lastly, Future Factory, which focuses on robotics automation, extended reality, and what they term manufacturing process informatics, which is I would call a synonym to IIoT, strongly aligns with the Advanced Robotics for Manufacturing Institute in Pittsburgh. So I want to be really clear that not only are we aligned with these programs, we actually serve on their boards as the government CTOs. And on the bottom left of the slide, you see some other potential areas that I see when the timing is right for ManTech investment, just something to think about. And if you have any questions there, I'd be happy to answer them. Next slide, please. So I think we kind of know this, but there was an interesting article that came out in 2019 that does a very nice job from Deloitte, that does a very nice job on basically explaining where we are right now in pushing these different use cases and what those use cases can provide. So we've already been really good for understanding failure modes and detailing them, monitoring those known failure modes, using better scheduling techniques if we have a sense of how we can reconfigure production lines. I think now we're really finally getting into this idea of condition-based monitoring, predictive maintenance rather than reactive, and then also this idea of adaptive quality management when something changes. Similarly, we've already achieved airworthiness for some additive manufacturing parts. I think the next frontier is combining new types of novel materials to really optimize some of those particular systems. And lastly, on the automation side, for years, even since the 80s, we've been quite good at developing automated systems that are in high volume scenarios, for instance, in the automobile industry, and also monitoring what we already know to be critically failure prone systems. I think now we're really reaching a point where not only can we push those concepts to more adaptable and agile systems, like the example in the sustainment depot that I showed before, but we're also able to present data in a more digestible form, kind of like your next generation of YouTube videos through AR headsets or any other means. Next slide, please.
And Bill, if you give us 1 second, we're going to switch to Becky to share the public release form. So she's going to hop in really quick.
Okay, so how are we doing, right? So there was this report that came out from McKinsey in 2011 that said by now, by 2020, we should have received these benefits: 50% lower product development costs, 25% lower operating costs, and so on. Yet its revision to that report came out recently that said we've only captured 20 to 30% of what was promised 10 years ago. And I think this really dovetails very well with Professor Hill's messaging, that we still have this siloing of data within legacy IT systems, but then also encapsulated within individual hardware and OT. So we have a lot left to do, which means that we're trying to break down these barriers of let's use standards as an example, rather than a standard that's printed out as a PDF that somebody has to interpret and then encode within their system. The standards community is moving towards a model-based standards development process where those standards can be ingested in a computer or machine readable way. Again, this workshop that we just had spoke a lot about that, OEMs, it's a huge pain point for them and able to adopt new techniques. Next slide. So this gives a snapshot of what the Digital Enterprise ManTech program is meant to do. There's 3 key thrust areas, focusing on digital supply chain, which is mostly focused on security transfer of information across OEMs to smaller vendors and suppliers. We have a very large focus, and there's going to be an announcement coming out soon on how we can build methods to move manufacturing and sustainment left, how we can adopt notions of similarity, for example, of existing systems to better enhance design practices of future systems. And kind of underlying all those notions is this idea of digital threading, meaning like if I query a particular problem within my manufacturing system, what data is being tracked back to me to answer that question. And then also for live and dynamic data, we're also very interested in digital twin. And foundational to these thrusts, I would say, are modeling capabilities, real-time analysis for prediction, and of course, my favorite coming from NIST last few years is this idea of data interoperability and connected data. Next slide, please. From the AM ManTech program, I really like their catchphrase, as big as we need, for maybe you can guess the application for what Mr. Phillipson hinted at, as small as we can with the confidence to fly. Like I alluded to before, our recent big ticket item here is how we can expedite quality management, specifically for airworthy qualification of AM parts and processes. When something changes up front, the existing protocols and standards simply are not good enough for us to get things off the ground faster. Next slide, please. And our last ManTech program, again, this is kind of just a snapshot of what we're doing in this space, is the idea of implementing better human-machine and machine-machine interfaces. We focus, at least in this program, on deploying or at least demonstrating these agile and connected robotic systems within sustainment, within our partners and customers across the Air Force depots. And we are now really focused on how we can leverage human-computer interfaces to engage the human into the robotic process. Next slide, please. So pathways for collaboration, how you can work with us. Like I alluded to, our ManTech programming you see on the right is very aligned, and often calls for proposals come out through the ARM Institute, America Makes, and MXD. My other colleagues across RXM also have alliance with CMANI, which is a cybersecurity manufacturing institute. We have a strong partnership with NextFlex, which is the Hybrid Electronics of Manufacturing Institute. I will also mention that from time to time we come out with specialized calls with our partners at SpaceWorks and AFWorks. If we see a particular area of interest through that could be solved through possibly a CIBR, and then we always engage through our Open BAA process. There is a specific Open BAA announcement live on the sam.gov website specific to ManTech. And on the top right there, coming soon, we are about to stand up a new digital manufacturing consortium called DRIVE. So please be on the lookout for that announcement, and we'd be happy to share with OFRN once that gets solidified and there are ways or clear pathways of joining that consortium. Next slide, please. So here's some technical contacts for each of the individual ManTech programs. Feel free, if you want, to reach out to me directly. If it's a bit fuzzy, if, for instance, your interests lie within Future Factory or Digital Enterprise, we get that question a lot. I'd be happy to connect you with who can give you more direct access and information for how you can collaborate. Thank you very much.